Okay, this lesson is going to be about exponent rules, and the first thing that we're going to do is kind of explore what exponents mean. So I have this example, negative 4x to the third. What does that mean? It means I have negative 4x times itself 3 times. So negative 4x times negative 4x times negative 4x. And these are called the factors of the problem, in case you're wondering. But again, the power tells you how many times you're multiplying that particular item. So if we look at x to the third times x to the fourth, you guys have been taught the rules, but we're going to talk about where that rule comes from here. If you write that out, x to the third means you have x times x times x, and then x to the fourth means you've got 4 of them, and you're multiplying those. And so if you look, that is where the fact that you get x to the 7th comes from, because there's 7 of them listed out. And that is where your rule comes from. So if you list out however many you have in the first one and however many you have in the second one, if you're multiplying, you just add those up to get that total. And so our rule, which I'm doing rules in purple here, x to the m plus, or excuse me, that should be a times x to the n, is when you add. So x to the m plus n is our rule. And again, sorry, that should be times in between those. Okay, now let's look at the division. So x to the 5th over x squared, what does that mean? That means we have 5 x's on top multiplied by each other and 2 x's on bottom. And so if you think about what happens there, they actually kind of cancel out, some of them, and that leaves us with 3 x's on top, which is x cubed. And so what happens is you look at the rule. How did you get 3 left? And you subtracted 5 minus 2, that'll give you 3. But where it comes from is actually canceling out. So our shortcut rule down here in purple is x to the m minus n, and we will talk about the negative exponents a little later on. Another rule can be found when we do something like this, so x squared cubed. This kind of goes back to that original example. What does that mean? That means I have x squared times itself 3 times. And so if I wrote out the x squares, how many would I have? I would have 6 x's. 2, 2, 2 makes 6. And so that's where our rule comes from. We add we multiply the x's when they are power to a power. So x to the m times n is our rule. And moving on. I don't have numeric examples for these, but it does come up sometimes that people think about having 2 different variables or a number and a variable to a power. What can you do? Well, that power applies to everything in the parentheses. So if you need to separate it, it actually applies to both. So you could say this was x to the m and y to the m. Or if it was a fraction, that would be x to the m over x to the, y to the m. So that power applies to everything in the parentheses. The last rule most people know, anything to the 0 power is 1. So x to the 0 power is 1. And if you need to write that down, write that down. Alright, let's move to our examples. Okay, so let's look at some examples. Example 1, we have y to the 4th times y to the 7th. And so this is the situation where we just add the exponents, and 7 and 4 is 11, so we have y to the 11th. Okay, and then we move on. We have x to the 6th over x, and that is an understood 1, so we subtract the powers. 6 minus 1 is 5, so this becomes x to the 5th. Now 3 is the situation that I was talking about when you get a negative. So when you do 2 minus 5 as your powers, just like we did in number 2, you get a negative 3. and that negative means it needs to move to the bottom. So that would be 1 over x cubed. But if you think about the canceling, you could actually just skip this step in the middle, because if I had 2x's written out on top and 5x's written out on the bottom and I cancel them, you would know that there would be the 3 left on the bottom and you wouldn't have to write this negative. So you really don't even have to think about the negatives if you think about where the rule comes from. Okay, next few examples here. I have, excuse me, technical difficulties. Okay, I have a power to a power. I have y to the third to the fifth, and that's the situation where we multiply. So that will be y to the 15th. And number 5 is similar, except I put the -3. And you have to remember that I said when you have a power and a couple of things in parentheses there that are multiplied, you can distribute that into both of those. And so this is like having -3 to the 4th, which I'm going to put in parentheses because it has the negative with it, and then x to the 4th. And things are disappearing on me. So then have to work and say what's -3 to the 4th, and so that's -3 times -3 times -3 times -3. So that should end up to be positive, and then 3 to the 4th is 81. So this is 81x to the 4th. Number 6 is one of those, again, I'm talking about how we can take that power to both things. And so this would be t to the 3rd over 5 to the 3rd. And I'm not putting this 5 in parentheses because it doesn't have a negative. You can if you want to, just to be on the safe side. And then you can simplify that if you want to. So 5 to the 3rd would be 125. And moving on. Example 7. I have a couple of things multiplied. All this is multiplied, so any variables that have that are the same, I can add their exponents. The -3 does not have a number to multiply with over here, but if it did, you would just multiply the two numbers. We have an example in number 9 where we're going to do that. So here I just get the -3, and then I can add my exponents for the x's and get x to the 5th, and add my exponents for the a's, and this is an understood 1, so I get a to the 4th. Now number 8 is a situation where I do have several things that I can take this 3 to. This is a -3 inside, and I'm going to take it to a 3rd power. So again, I'm going to put that in parentheses. That just makes sure that when I type it in my calculator, I use the right sign and get the right answer sign-wise. Then x to the 4th to the 3rd is like a power to a power, so I'm going to multiply and get x to the 12th. And then I'm going to have 2 to the 3rd on the bottom because that 3 had to go, that 3 power had to go to every piece. Now with the top, -3 to the 3rd should be a negative because a negative times a negative times a negative is negative. And 3 to the 3rd is 27. So -27 is what that becomes. And again, I have the x to the 12th. And then 2 cubed is 8. So I'm just simplifying those. Number 9 is a situation where I have a number now in both parts. You multiply just like as if it were -4 times 2 was your problem from elementary school. So -4 times 2, we get a -8. Then you just add the powers of the variables that are the same. Now there's an s in the first one but not in the second one, so you just kind of bring it on over. And then for the t's you add and get 7th power. 10 is the same way, so if you want to pause and work that one out and see if you can get it, that would be great. Okay, so if you worked out number 10, you should get -36 w to the 5th y to the 8th. And if you did not get that and you want to raise your hand, I will help you. Alright, number 11 is another big one with a big parenthesis. So there's a lot of stuff that this 3rd power is applying to. Again, I have a negative here with the 2. So I'm going to make sure I put that in parentheses before I give it the 3rd. And then with these variables, it's a power to a power rule, so I multiply. So I have w to the 6th and y to the 9th. And then on the bottom I have 3 to the third. And from there I just have to simplify my numbers. So negative 2 cubed is negative 8. And bring my variables over. And then 3 cubed is 27. And then our last example, I gave you a bunch of ugly stuff, but it's to the 0 power, and anything to the 0 power is 1. So that concludes this review of exponent rules.